Sometimes, the history of science moves forward not just through genius, but thanks to unexpected accidents and serendipity. That's exactly what happened in a London laboratory, where Scottish physician and scientist Alexander Fleming returned from a short holiday to inspect some forgotten petri dishes. As he sorted through his experiments, he noticed something strange. On one of the dishes containing Staphylococcus bacteria, a green mold was growing, surrounded by a clear area completely free of bacteria. Wherever the mold spread, the bacteria vanished. Instead of dismissing it as mere contamination, Fleming decided to investigate further. He discovered that this mold, identified as Penicillium notatum, produced a substance capable of killing many harmful bacteria. This was the birth of penicillin, the first modern antibiotic, a breakthrough that revolutionized medicine and has since saved millions of lives around the world. But the journey wasn't easy. Fleming published his findings, yet for years, no one managed to isolate pure penicillin. It wasn't until scientists like Howard Florey and Ernst Chain took up the challenge that penicillin was finally developed into an effective drug. The accidental discovery of penicillin reminds us that careful observation and curiosity can turn a mistake into one of humanity's greatest advances. But this wasn't the only time. In the next segment, we'll see how a simple kitchen mishap led to the invention of a device now found in millions of homes. Sometimes, the greatest breakthroughs arise from the most unlikely accidents. Percy Spencer, a curious and self-taught engineer, was working at Raytheon, a company focused on military technology, when fate intervened. While experimenting with a magnetron, a special tube that generated electromagnetic waves to improve radar, Spencer noticed something odd. The chocolate bar in his pocket had mysteriously melted. Instead of dismissing it, his scientific instinct took over. He placed popcorn kernels near the magnetron and watched in amazement as they popped into fluffy popcorn. Next, he tried heating an egg, which quickly exploded from the pressure. Through these experiments, Spencer realized that microwaves could heat food from the inside out, thanks to the rapid movement of water molecules. With a team of engineers, Spencer designed the first microwave oven. It was huge, heavy, and expensive, initially intended for restaurants and industrial kitchens. The key was directing the microwaves safely inside a metal box, concentrating the energy to cook food quickly and evenly. This invention revolutionized modern cooking, making it possible to heat and prepare meals in minutes, forever changing our eating habits. From a melted chocolate bar to an essential appliance, the microwave reminds us how curiosity and mistakes can transform the world. But this is not the only remarkable invention born from chance. In the next segment, we'll explore how a chemical mishap led to the creation of Teflon, the non-stick material that changed the way we cook. The DuPont laboratory in 1938 was a place of relentless experimentation and discovery. Here, a young chemist named Roy Plunkett was trying to develop a new refrigerant gas, a job filled with precision and patience. His routine involved storing tetrafluoroethylene gas in pressurized metal cylinders, expecting it to remain stable until needed for experiments. One day, when Plunkett tried to release the gas, he found the valve stuck, even though the cylinder felt full. Puzzled, he investigated further. Upon cutting open the cylinder, he found a white, waxy powder clinging to the walls. The gas had vanished, replaced by something entirely unexpected. Unbeknownst to him, he had just witnessed the spontaneous formation of a new material, polytetrafluoroethylene, now known as Teflon. This compound, born from a procedural error, had remarkable properties. It was heat-resistant, nearly immune to chemical corrosion, and extraordinarily slippery. What started as a failed experiment quickly became a breakthrough in material science. Teflon soon found its way into industrial uses and, decades later, entered millions of homes as the non-stick coating for cookware. Its story proves that curiosity and determination can turn an accident into an innovation that helps countless people. Sometimes, the most unexpected mistakes lead to world-changing discoveries. And if you think serendipity is reserved for chemistry, just wait to see how pure chance has shaped the history of physics. Sometimes, mistakes don't just cause accidents. They open the door to inventions that change the course of humanity. This is exactly what happened with dynamite and Alfred Nobel. Nobel was a Swedish chemist deeply fascinated by explosives. At the time, nitroglycerin was the most powerful substance known, but it was so unstable that even a small bump could trigger a devastating explosion. Determined to make it safer, Nobel experimented with many materials, but none worked, until what seemed like a mistake. He mixed nitroglycerin with a porous earth called diatomite. The result was astonishing. The diatomite absorbed the nitroglycerin, making it safer to handle and much less likely to explode by accident. This is how dynamite was born, a much safer, easier-to-use explosive. Dynamite revolutionized mining, tunnel construction, and the building of infrastructure that once seemed impossible. However, dynamite's success came with an unexpected side. Although Nobel intended to advance industry and aid major projects, dynamite was soon used in armed conflicts, leading him to deep regret. The very error that stabilized nitroglycerin changed not only science, but also Nobel's conscience, inspiring him to leave a positive legacy: the Nobel Prizes. But the story of accidental discoveries doesn't end here. Our next segment dives into a medicine that saved millions, all thanks to another laboratory mishap. Sometimes a mistake or an unexpected intuition can transform millions of lives. That's the story of insulin, one of medicine's greatest revolutions. Born from an idea that seemed improbable and an improvised laboratory, Frederick Banting, a young Canadian surgeon, wasn't an endocrinologist or a chemist, but he was obsessed with understanding diabetes. Inspired by readings about the pancreas and frustrated by repeated failures, Banting proposed an unusual surgical technique to isolate a mysterious substance: insulin. Nobody expected it to work. Yet, alongside Charles Best, he managed to extract a crude liquid from a pancreas that, when tested on diabetic dogs, miraculously reduced their blood sugar levels. They repeated and adjusted the experiment, and after many setbacks, came the decisive moment: the first human injection. Leonard Thompson, a teenager on the brink of death from diabetes, received the treatment. The first dose wasn't perfect, but the team didn't give up. They refined the extract, and days later, Leonard showed an astonishing recovery. For the first time, diabetes was no longer a fatal sentence. This discovery wasn't the result of a meticulous plan, but of the courage to try the improbable and to learn from mistakes. Insulin, a hormone once thought unreachable, became hope for millions. But the story of accidental scientific breakthroughs doesn't end here. In the next segment, we'll visit another laboratory, where a simple X-ray would reveal an invisible world. While many of the greatest scientific breakthroughs are the result of deliberate searching, others, like X-rays, are born from pure chance. German physicist Wilhelm Conrad Röntgen was in his lab, investigating the effects of electricity on cathode ray tubes. One night, he noticed a strange glow on a screen coated with barium platinocyanide, even though the tube was shielded by black cardboard. Something was passing through the cardboard and activating the screen, but it wasn't visible light. Curious, Röntgen began experimenting. He discovered that these unknown rays could pass through solid objects like wood and flesh, but not bones or metal. To test his idea, he asked his wife to place her hand on a photographic plate and activated the device. The result was astonishing. The first image of human bones captured without surgery or pain, marking the birth of medical radiography. The impact was immediate and profound. X-rays revolutionized medicine, making it possible to see inside the human body and opening new doors for diagnosis, surgery, and scientific research. The news spread worldwide, and Röntgen received international recognition, including the very first Nobel Prize in Physics. This accidental discovery didn't just change medicine. It inspired new fields in science and technology. The era of medical imaging had begun, all thanks to a mistake and the relentless curiosity of one researcher. But not every fortunate discovery changes millions of lives. Some, like the next one, began as a personal quest and ended up altering our understanding of the mind itself. Among the most astonishing accidental discoveries, few can rival the story of LSD. It all began in a Swiss laboratory, where chemist Albert Hofmann was searching for treatments for circulatory problems using compounds from a rye fungus. After synthesizing dozens of derivatives, he created a molecule that initially seemed harmless and without practical use. Years later, a simple gesture, touching his face after handling the substance, would change the course of science and human perception. Hofmann soon noticed strange sensations, a deep alteration of perception and senses. Intrigued, he decided to experiment under controlled conditions with a very small dose. What followed went beyond anything he could have imagined. His vision distorted, time seemed to expand, and his emotions swung between fear and euphoria. This episode, now known as Bicycle Day, became the first recorded psychedelic journey, revealing that LSD had a far more powerful effect on the mind than anyone expected. Although the original goal was to develop a physical medicine, LSD unveiled a completely new potential for exploring the boundaries of consciousness. Both the scientific and artistic communities quickly became fascinated with its effects, leading to years of research into its possible uses in psychotherapy, creativity, and its risks. LSD opened a new chapter in the science of the mind, showing that even mistakes or accidents can unlock doors to unknown worlds. But if you think chance had already done its part, wait until you hear how a failed formula led to one of the most iconic adhesives ever created. Sometimes, a mistake can be more valuable than a success. The story of the Post-it proves just that. A small piece of paper that now fills offices, homes, and schools worldwide. After exploring the unexpected effects of LSD, let's journey into a 3M laboratory, where a failed adhesive changed the way we organize our lives. In 1968, chemist Spencer Silver set out to create a super strong glue for the aerospace industry. Instead, he ended up with a low-tack adhesive made of tiny acrylic microspheres, one that could stick and unstick repeatedly without leaving any residue. For industry standards, it was a failure. For creative minds, it was an opportunity. For years, Silver shared his discovery with colleagues, but no one seemed to see its potential. Everything changed when Art Fry, another 3M employee, needed a way to mark pages in his hymn book without damaging them. He remembered Silver's adhesive and decided to try it on pieces of yellow paper, the only color available in the lab. That's how the first Post-it prototypes were born, sticky notes that could be attached, removed, and reused with ease. Success didn't come overnight. The first product launch flopped. Consumers just didn't understand what it was for. Only when free samples were handed out in offices and people tried them did the revolutionary potential become clear. The Post-it went on to become a global phenomenon, proving that perseverance and curiosity can turn a mistake into an indispensable tool. But this wasn't the only accidental invention to transform our daily lives. In the next segment, we'll see how another error led to a material you probably use every day, often without even noticing. The next major scientific mistake that changed history happened, like many in this series, inside a laboratory. Plastic, now everywhere in our lives, was born from a series of accidents and unexpected ingenuity. The first milestone came in 1898, when German chemist Hans von Pechmann heated diazomethane for research and discovered a white, waxy residue at the bottom of his test tube. The substance was truly novel, but its true potential was not yet understood. Pechmann's colleagues analyzed the material and found it consisted of long chains of carbon and hydrogen, the first polyethylene, though they called it polymethylene at the time. For decades, this finding remained a mere laboratory curiosity. More than 30 years later, in England, new researchers accidentally synthesized polyethylene by applying extreme pressure to a mixture of gases. A defect in their equipment let oxygen leak in, and without intending it, they obtained that same waxy material once more. This time, its useful properties were recognized, lightness, strength, and insulation capabilities. Plastic began its meteoric rise, revolutionizing packaging, medicine, construction, and daily life. What's fascinating is that plastic, a symbol of modern innovation, emerged not from intention, but from chance and error. Today, its use is so widespread that it's hard to imagine life without it, even as it presents major environmental challenges. The story of plastic reminds us that science often advances along unexpected paths. In the next segment, we'll explore another accidental discovery, how a failed experiment led to the birth of modern anesthesia. Sometimes, mistakes become the spark that lights the way in science. Modern anesthesia, a miracle that allows surgery without pain, was born from a failed experiment. Before its discovery, facing surgery was a terrifying ordeal. Patients endured extreme suffering, and doctors could only witness pain, powerless to relieve it. Everything changed in the mid-19th century when Horace Wells, an American dentist, witnessed a demonstration of nitrous oxide, known as laughing gas. Fascinated by its potential to eliminate pain, Wells tried the gas on himself during a dental extraction. The result was astonishing. He felt no pain. Convinced of his discovery, he attempted a public demonstration, but made a crucial mistake by removing the gas too soon. The patient cried out, and the audience dismissed the experiment as a failure. Yet, this error did not halt progress. William Morton, Wells' disciple, continued the research, experimenting with ether and achieving deeper anesthesia. During a historic demonstration at Massachusetts General Hospital, Morton showed that ether could enable surgery without pain. The discovery quickly spread worldwide, revolutionizing medicine and saving countless lives. Today, anesthesia is essential for any surgery, and its development reminds us that even failures can change history. Next time you enter an operating room, remember, behind every breakthrough, there's a story of perseverance and learning. If you enjoy these stories where destiny is defied, subscribe to the channel and share the series so more people can discover how science learns from its mistakes.